but a starry night sky is nothing short of magical. People have long been fascinated with the stars, the sun, and the moon, and have attempted to find meaning in what they saw in the sky. The Inca civilization placed great importance on astronomy and their calendar. So in this lecture, we will be exploring the Inca calendar, their perception of astronomy, and you will also learn more about the quipu. When trying to understand Inca astronomy and their calendar, most important are the ethnohistoric records of Spanish and Quechua chroniclers who noted that the Incas were stargazers and measured heavenly movements. The sources are complemented by archaeological and archaeoastronomical investigations in order to ascertain a broad perspective on what the Incas were looking at when they gazed towards the sky. It should be considered that the Spaniards who recorded astronomical information themselves had little training or understanding in the intricate workings of celestial objects, although some would have been familiar with them from a navigational perspective. Overall, the relationship between astronomy and calendrics was tied to Inca power, religious structures, and agricultural practice. The term calendar holds two meanings for the Inca. First, as a conceptual scheduling system, and second, as the symbolic representation of that system. Now, there are numerous references to Inca calendrics in colonial era sources, though few have details on how the Inca actually managed either the conceptual or symbolic framework of the calendars. So a main point of conflict in understanding the Inca calendar is whether they followed lunar months, solar months, or a combination of the two. Essentially, a lot of sources disagree on the use of solar or lunar calendars, so what I'm going to do is actually discuss both. In general, what we know is that they used calendars to regulate social activities in both time and space. Spanish chronicler Juan de Betanzos, in his Narrative of the Incas, provides a detailed account of the Inca calendar, laid out in months and days that Pachacuti himself had imagined. According to Betanzos, Pachacuti created the Inca calendar, which consisted of 12 months of 30 days, for a total cycle of 360 days. This calendar was inseparable from the Inca festival or ceremonial calendar, which was established using lunar cycles. Hence the conflict, since this annual calendar was established using solar cycles. If the annual calendar and ritual calendar got out of whack, then they added up leap days or weeks to bring the calendars back into sync. The calendar, with its complementary overlay of rituals and feasts, is thus very closely tied to the agricultural cycle. Betanzos also said that at the same time Pachacuti created the calendar, he also created the Pacha Unam Changa, which was a clock that helped keep track of the calendar, as well as when to sow and prepare the land for agriculture. Pachacuti established the clocks by watching the sun and the moon. So every morning and afternoon of every month of the year, he would take note of the times to plant and harvest. And when the sun went down, Pachacuti made note of the moon according to when it was new, full, or waning. Then he constructed the clock out of cut stones placed on top of the highest hills, set in line with where the sun would rise and set. So this clock would also aid commoners since they were able to see it, and they too could then calculate the best times of year to plant their food. So aside from Betanzos' accounts, what do we actually know about the lunar and solar calendars? Let's begin with the lunar calendar. According to the Inca, the lunar calendar divides the year according to the phases of the moon, which are either sidereal or synodic. In the sidereal calendar, it calculates the moon's revolution in the sky in relation to a star's position, which equals to approximately 27.3 days. Now, the synodic calendar, on the other hand, consists of months based on the phases of the moon, which is equal to approximately 29.5 days. Thus, 13 sidereal months is equal to 354.9 days per year, while the 12-month synodic calendar is equal to 354 days per year. Now, there are obviously some issues with this. Neither the sidereal or synodic calendars correlate with the 365-day solar year, making the inner calculation of a short month necessary. If this calibration is not done, the correlation of the annual calendar and the ritual calendar would very rapidly cease to overlap. Thus, what would end up happening is planting would occur in the winter season, which would be bad. Now, there is some symbolism associated with this. The moon, and thus the lunar cycle, is associated with the feminine and female counterpart of Inti, the sun god. The common name in Quechua for the moon is Kia, and as such it is associated with the deity and goddess, wife mother, Mama Kia. Although she is sometimes called Warmi Mayor, the principal wife, or Koya Kapak, noble queen, you're going to find that she's most often referred to as Mama Kia. The phases of the moon were used as a metaphor for the human life cycle. So a full moon was referenced to an adult, a half moon an adolescent, a quarter moon a baby, and a crescent moon meant just born. Okay, let's switch gears to the solar calendar. And what do we know of the Inca solar calendar? Well, we know, much like our calendar today, it was demarcated by the return of the sun to its specific solstice point every 365.25 days. It is at these solstice points that the sun, in effect, turns back on itself and reverses its direction north to south or south to north. The Inca, as I mentioned, constructed stone pillars on the hills above Cuzco in order to keep track of the sun's movement. These pillars lasted hundreds of years after Betanzos first recorded them, as they pop up in various chronicler accounts. However, the amount that existed is different among different sources, so we're actually quite unsure on how many actually existed of these clocks. Some say 14, some say 16. All solar observations were marked against the horizon, as that never moved. They were actually probably watched from a central point in Cuzco, the most likely location being the Usnu, which is a central platform. Shadow casting via a gnomon or certain openings such as windows were also utilized to track the movement of the sun. And as I mentioned in the previous slide, horizon pillars were placed above Cuzco and various other high hillsides. According to eyewitness accounts of an unknown Spaniard, he was referred to as the anonymous chronicler or the anonymous conqueror. 4 solar pillars were placed on the horizon above Cuzco. The 2 outer pillars were about 200 paces apart, while the inner 2 were 50 paces apart and were used to track the movement of the sun. And, well, that's it. That's what we know of the lunar and solar calendars. With this in mind, we must ask the question, how then did the Inca measure time? We do know that the Inca had terms or words that referred to lengths of time. For example, the word for year was huata, month was kia, and a day was called a punchayo. Now, Kia being the same name also used for moon, and Punchayo is the same name used for the golden idol stored at the Coricancha in Cuzco, which we're going to cover in a different lecture. The Inca did not have words that distinguished days of the week, and whether or not they adhered to the idea of a week is actually still debated. Now, we do know that outside Cuzco, there is reference to a 10-day week found throughout the Andes, but it was supposedly never used in Cuzco. Thus, time was not recollected according to hours and minutes. Rather, they judged time by the duration of an event or common task. For example, an amount of time might be expressed as the time it takes to walk to the next village, or most commonly, the time it takes to boil water. Observing the sun and the moon for maintenance of the calendars required an element of astronomical understanding. So, what exactly do we know of their understanding of astronomy? Well, a fair bit, actually, thanks to the Huarochiri manuscript. This manuscript is a colonial-era 31-chapter document that was written by an indigenous author in Quechua. It records pre-Hispanic Andean religious traditions and recounts myths, as well as details of the Andean relationship to Huacas, and tells of both Inca and Spanish imperial aggression. Additionally, and most importantly for this talk, it contains information concerning astronomy. Based on what was written, it is suggested that the Andeans saw patterns in both positive and negative space. That is, observation accounted for the forms of stars, star clusters, as well as the dark space between the visible light. And according to the manuscript, at least some of the dark spaces contained the power of animation. The manuscript also describes the Milky Way and the Pleiades, as well as the Akana. The Akana is the animator which resides in the Milky Way and was responsible for creating the heavenly counterparts of all animals and birds on Earth. According to the Huarochiri manuscript, the Inca had individuals who were trained at watching the movements of the sun and the moon, and they were called the Yanka. It was basically their responsibility to watch the shadows cast by the nomons. And the manuscript suggests that these persons were present in all villages, not just Cuzco. In addition, they were also accountable for the temporal maintenance of the ritual and festival calendar for each location. Now, obviously, given the significance of the sun, there were specific locations where worshippers could pay tribute to the sun. Many huacas in the Sakai system are referred to as houses of the sun, and these houses had doorways and windows that aligned with solstitial observation, or the buildings themselves were considered a sundial as a whole. The two most famous houses of the sun were the Coricancha and the Torreon. The Coricancha in Cuzco is believed to be where the Sapa Inca would have made astronomical observations. The direction and alignment of the Coricancha coincides with the direction of a Sakai line that points closely to where the Pleiades rose on the horizon. Now, the Torreon at Machu Picchu, also called the Observatory, is a rock outcropping with an interior space dominated by a large altar. There's a masonry wall that encircles the stone altar, as you can see here, with a window cut into it. And as the sun moved throughout the year, it cast a different shadow on top of the altar, essentially. So a cut into that specific large altar at the center aligns with the June solstice and can allow for one to monitor time. Accounts of stellar observation are numerous, but much less thorough. Most of the standard chronicles only make passing references to the stars themselves. As it was observed, the Inca did not distinguish between stars and planets. They probably had no idea what a planet was or if they even existed. So what they used is a term called chasca, and chasca is a Quechua term for shaggy hair. And this was used to refer to the most brightest stars and planets. The Inca did correlate the sun, moon, and stars to their mythology. For example, there is a story of the Golden Star, which relates to the rising of the Pleiades and the Huacas. Essentially, the Golden Star was given as a gift at the coronation of an Inca ruler. The Golden Star walked a certain road, though frequently stopped to rest. It has been suggested that these rest stops are huacas. Many debate whether or not the Sakai system functioned as a calendar. Now, there are 328 huacas, perhaps representing each day of the year, with some having been lost throughout time. And according to chronicler Kobo, some Sakais combined with huacas acted as markers of the sun, known as solstitial markers. The Inca also recognized other celestial phenomena. For example, the Inca believed the Milky Way was a river of recirculating water and that it drew moisture into the atmosphere, which was then carried to the cosmic sea, which they believed surrounded Earth. Now, for the Inca, on the other hand, eclipses were something to be feared. A solar eclipse caused great fear and threatened the existence of the world. And with a lunar eclipse, they thought Mama Kia had died and that she was going to fall and crush them all. Regardless, the Inca would perform sacrifices to bring the sun and the moon back. Now, also something to be feared by the Inca were comets. The Spanish documented this and recorded that they believed that this was a signal of something ominous, like the death of a loved one. While astronomy could leave much up to the imagination, one thing was for sure: the Inca had a definite grasp on their mathematical system. The primary element was their quipu, which was used for recording specific types of information. Most often it was associated with accounting or counting of objects. Essentially, a quipu is just a length of cord from which a series of strings were suspended. It could be used to record census data, the amount of storage contents, tax obligations, military organization, calendrical information, and land measurements. The quipu was not original to the Inca and had been used for thousands of years prior to their existence. As I've mentioned before, the quipu made use of a base 10 number system. Thus, they methodically counted items grouped into tens, 100s, 1000s, and 10,000s. The pendant cords, so the ones that were attached to the primary cord, were twisted and knotted in specific ways which indicated a number, with the position of the knot indicating its specific numerical value. Now, the color of the strings could also indicate the specific context or what was being accounted for. Now, who made the quipu? Well, that actually fell to quipu kamayos, who were the individuals responsible for constructing, keeping, and reading the quipus. Now, this system was so reliable that the Spanish even used it. So if you go back to the module, you're going to find that the assignment for this module, called Talking Knots, is going to introduce you to the specifics of how to calculate a quipu, how to actually count those knots. So I suggest you spend some time reading through the link which is included in the assignment directions, focusing on a page called What is a quipu? A good point to make here is that there are different links on the right-hand side, so go through those different links. Get a very basic understanding of how quipu works, then do the assignment. All right, good luck.